Buenos dias, fuckers. Not Einstein, Newton. And the apple. And then gravity. What if it had been a tennis ball? Huh? What would he have said? He would have probably left it too complicated, wouldn't it? Apple falls from a tree, boom, stays there. Gravity, the moon, the planets, elliptical orbits, wow, the tides, everything. I was going to do this with Newton, but I've had a good look. I reckon we'd do it without Newton. So, this moon is too small for this Earth. It's only about 7 centimetres. Now, here's the thing, right? Here's the thing. There's a few things going on. I'm not so keen on them myself. We look at all this spring tide, depending where the moon is. Sun's there, okay, permanently. We'll leave that there for now. We've got moon's going that way, right? Earth's spinning that way. So we have 4 different settings, right? Well, there's 2. Now, it is said, this is the one that I can get. The moon and the sun are both on that side. Earth, it's kind of got 2 gravitational pulls to deal with, isn't it? Then the moon comes round here, right? And they say, so you've got spring tides there, 2 big tides, and then the moon slips down to the first quarter of its trip. And they say that the sun blanks out the moon's gravitational pull. This is where we have neap tides, because they're at right angles to each other. But I would have thought this would have been one of the most chaotic moments on the planet, because you have the moon pulling down that way, you have the sun pulling this way. Would the water not be like all over this side? I mean, it's gravitational pull, isn't it? So why are they going to cancel each? What? No, they say the sun cancels the moons out, even though the sun only has half of the moon's gravitational pull. So wouldn't it be the moon cancelling the sun's out? Look, it's irrelevant. If you've got a rope pulling down here and another rope pulling here, what's going to happen? You're going to get a bit of a tight area up there, and I'm using common sense here, okay? I know, Simon Dan, if you're watching, I'm sorry. It's not science, is it? It's bollocks, really. Think about it. So, for me, when they're at right angles to each other, and you've got that pull there and that pull there, it's going to be chaos up here, isn't it? It's going to be all over the shop trying to get off. And then we get to the half. Bang! Right, so we've got the full solar eclipse now. Now here, it is said that the sun, earth, and the moon are all in line. So we have spring tides again, the big tides. But if the moon is pulling here, and the sun is pulling here on this one, don't forget the moon has got just over twice the amount of pull that the sun has. Is it logical to think that the sun, with half the amount of pull from the moon, and the moon on the other side pulling, would there not be a little bit of this counteracting this here? And would there not be a little bit of this pull counteracting that pull? I just find it a little bit strange that when the moon's here and both of them are pulling this way, I get that. But then we have the moon over this side and it's still a spring tide, still massive tides. Doesn't make sense. It doesn't make sense, does it? But it doesn't. And then we go back to the 3/4 position. Now we have a pull here and a pull here. So we're going to have this tight area here and here. It's going to be chaos. The surface would be out. That's what I'm thinking. For me, when they're at right angles to each other, you've just got pull here, haven't you? How they cancel each other out? I get that they cancel each other out if they're opposites, but when they're both, one's in a 9 o'clock position and one's in a 12 o'clock position. Sorry for the people born after 2000, that's old time. Like we have clocks, we used to have clocks, right? And you've got, I'm joking. Now, there's one other thing here. One other thing. Oh, it just always bugs me. Earth has 6 times the gravitational pull of the moon. So why is it the moon, with its 1/6 of Earth's gravitational pull, and the sun basically with 1/12 of Earth's gravitational pull, might be a little bit less, or they say it's 2.5, so 12, 1/12. Earth, it's kicking ass, isn't it? So why is the moon going to be pulling that water if Earth's still got 5/6 of its gravitational pull to keep it here? And on this side, sun, do we really need Newton's absurdity to question this? Now here's the thing. I said this 7 centimeters should be 8.3 to go with this Earth here. Right? So what I've done, like I usually do, we're going to go outside in a minute. Right? Now, what we have, I've got my moon to scale, the 8.3 centimeter, and the other globe outside with 9 meters in between the two, perfectly to scale. So, what we have, this is my workings out. We have a 30 centimeter globe. There are 109 Earths in the sun. So, we've got a 30 centimeter globe outside and an 8.3 centimeter moon with 9 meters in between. We want to know what size the sun would be in this scenario. So we multiply Earth by 109, we get 32.7 meters. That is size of the sun, okay? That would be the size of the sun with the 30 centimeter diameter Earth that we're going to go outside and see in a minute, and the 8.3 centimeter moon, and the 9 meters in between the two. We want the distance now, don't we? So we have a sun with a diameter of 32.7 meters. We multiply that by 108, because there are 108 suns in between us and the sun. 150 million divided by 1,390,000, I think it's 107.9. We call it 108. So that equals 3,531 meters. So up here, when we go outside and we see Earth and the moon, we now can visualize a sun that is approximately 3.5 kilometers away, and it has a diameter of 32 meters. So 32 meters, what we're looking at, how many 3 meters for a, we're looking at a 10-story building, square, 10-story building, 3.5 k's away, right? A 10-story building, something like that, but square, right? So 10 stories up, 10 flights, 10 stories, and it's as wide as it is high, all right? 32 meters that way, and 32 meters that way. That's how big the sun that we're dealing with is. So now you can picture that, can't you? I mean, would you eat? I mean, you'd see it if it was the sun. It's quite a long way away, isn't it? Right, let's go and have a look. Now, can I zoom out enough? No, that's maximum zoom out. Right, over there. See that Earth dangling? 30 centimetre diameter from Earth. And the Moon, an 8.3 centimetre diameter moon. And there are 9 meters in between the two. I think you should be able to see that. I'm hoping. Look, you know what I'm going to do? I'm going to bring Earth in a meter, just so I know that you're seeing it. So it's a little bit shorter than it should be. So Simon, now you owe me a meter, all right? Is that one in your favour? I bet he's drooling at the mouth. He's thinking, I've got him this time. All right, so we've got planet Earth on the right, and we have das Moon on the left. And we have a sun. If it was behind the moon for maximum gravitational pull, it would be 3.5 k's away, pretty where TAFE is, and it would be a 10-story building, right? So what's happening? I'm just recording. I'm 10 minutes. Just doing a video. That's spinning. And this orbiting up here. So how far away it is. And the sun would be 3.5 k's away that way. And I go all the way around that Earth. This is to scale. Right, stop spinning now. Now, let's go back inside. It's a small moon, isn't it? Let me go and get that moon that is to scale. just going to pause you. All right, here it is. You saw how far away it was. Creating a bulge. Creating a bulge. And then a neap tide when the 10-story building that is 3.5 k's away from here, and when this is 9 meters down that way, that this apparently cancels that gravity. How does that cancel each other out? If that's pulling there, and this is pulling here, it's going to pull some, isn't it? And then that's going to pull some, and we're going to kind of have a bit of an area. I mean, if you did that with magnets, how are they going to cancel each other out? They're not opposites, are they? They're kind of working together at the 12 o'clock and 9 o'clock positions, aren't they? Here and here. So you'd think there would be chaos that way and that way. Look, it's highly illogical, isn't it? Who worked this bulge out again? Because I've been going back in the encyclopedias and it was mentioned in the 1961. They knew that there was a bulge. See, I thought it would be an absurd. I was accusing these people here of lying, thinking that it'd been made up 10 years ago. How on earth did somebody work out that there's a bulge? 1961. In 1980, they still didn't know what was causing the currents. See, there's this big mixed match going on, isn't there? Bit of a... None of it makes sense. In the 1980 book, they didn't even know what was making the currents. What? And Newton, his name came up, and thanks to Newton, the tides. Let me just read a little bit, seeing as we're here. Here's the number 3 book. There it is. Newton, hey, what are we going to do with you? Newton gave the first satisfactory and generally accepted explanation of colour phenomena. He began by experimenting rather idly with a prism, the wedge-shaped glass that causes the light of the sun to be broken up into spectrum, series of colours ranging from red to violet, as they are seen in a rainbow. In the year 1665, he wrote, I procured a triangular glass prism to try therewith the celebrated phenomena of colours. Having darkened my chamber and made a small hole in the window shutters to let in a convenient quantity of the sun's light, I placed my prism, that I somehow acquired in 1665, at its entrance that it might thereby be refracted to the opposite wall. It was at first a very pleasant divertisement. Now, sorry, that was a bit about light. God knew. Mortals, congratulate yourselves that so great a man has lived for the honour of the human race. This inscription on the tombstone of Sir Isaac Newton in Westminster Abbey is a fitting tribute to the great Englishman, God, who gave man new insight into the nature of the universe. But did he? Did he? Are we sure he's a shoulder of a giant? Are we sure? His friends and colleagues, recognizing his mathematical genius, urged him to write out his proof of this problem, which none but he could solve. It's a bit like that quantum thing, isn't it? But nobody understands it, but everybody loves it. Everybody's going crazy. Everybody's sacrificing common sense for, I don't know what. He had a cat, Newton. His cat could, right. He arrived at others in, hang on, that he cut a small hole in his door so that his cat could enter and leave at will. That when she presented him with kittens, he cut a smaller hole for them. That either he or the cat tipped over a candle and burned up notes on optics that had been accumulating for 20 years. What a way to lose all of those notes, isn't it? Kittens. What else is there? Oh, there's so much. Newton's supreme contribution to science was his theory of universal gravitation, as set forth in the Principia. Its cornerstone is the law that all bodies attract each other with a force proportional to their mass and inversely proportional to the square of the distance between them. Newton never defined mass. On Earth, in terms of terrestrial mechanics, it is usually equivalent to weight. Newton's three famous laws of motion also form a part of this theory. We did those last night. We don't need to do that. In the Principia, Newton shows how the law of universal attraction and the laws of motion apply to earthly phenomena. The movement of pendulums, bodies passing through water, sound passing through air. He also shows how the heavenly bodies obey these universal laws. Thus, two mutually attracted heavenly bodies describe similar orbits about their common center of gravity and also about each other. When three bodies attract each other, that's when the chaos starts. Certain irregularities in their orbits result. Thus, the moon's motion is irregular because it is attracted to and attracts the sun at the same time that it is attracted by and attracts the earth. Newton concludes that the celestial bodies making up the solar system move in accordance with the theory of Copernicus and that their orbits are determined by mutual attraction. On the basis of this doctrine, he gives an explanation of the tides. He points out that the highest tide occurs at times when the sun and moon reinforce each other's attraction for the earth, that the lowest tides occur when the sun and moon act against each other. 9 o'clock, 12 o'clock. Newton showed that comets, which had formerly been regarded as capricious phenomena, also follow the law of universal gravitation. He held that they move in parabolas. Now, how easy would it have been for him back then just to say, hang on, right, here's the comet thing, right? Look up there. How often, what does it say? Newton showed that comets, which had formerly been regarded as capricious phenomena, how do you do that? Right, come on everybody, it's comet night tonight. See that one? See how it's going that way? How do you show, if somebody here now wanted to show us how a comet works, because they wouldn't have had video recordings, it would be a bit complicated without any power and stuff. 1600s, mind. So how do you show the comets? See, there's so many absurdities, right? This is what he said. Listen to this. Yet he had the modesty of the true scientists. I do not know, he said, in a conversation recorded by Joseph Spence, what I may appear to the world, but to myself, I seem to have been like a boy playing on the seashore, now and then finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me. He said this. It was recorded by Joseph Spence. all the mathematical genius and scientific insight displayed in the Principia, it was nevertheless the new information on the motions of tides, offering practical help in the art of navigation, that won Newton a popular reputation and royal favour for his work. King. The kings of England might not have been able to understand Newton's abstract mathematics, but they acutely appreciated all discoveries that will contribute to England's progress as a seafaring nation. Astronomical and mathematical research won support in England because it was an essential aid to steal people's land off of them as the centuries ticked over. Now, doesn't add up. This doesn't add up. I know a lot of you, those of you without a common sense, when I say moon's up here pulling and the sun is there pulling, we're told that this is a cancellation of each other's gravity, but how is it? How? We're pulling, aren't we? They're ganging up on one side, on 90-degree angle. It isn't logical to think that they would be the smallest tides, is it? Here, if there was a gravitational pull, yeah, big. But when it moves to here, don't forget, it only takes 1.3 seconds for the gravitational pull from the moon to start hitting there. The sun, 8 minutes and 20 seconds. So whatever's happening here, it's going to take 8 minutes and 20 seconds for, yeah, whatever. Now, look, I don't think we need Newton. We don't need to show him up, do we? I think it's all there. The sizes. The sun has only got half of the moon's gravitational pull, just under. They say the moon has 2.5 of the sun's. But Earth has 6 times that of the moon and 12 times that of the sun, but they're still bullying us. How does that happen? We've got all of that gravitational pull, keeping all the water on the planet, and the moon's trying to pinch it, and the sun. Are they though? And then we have, there's a thing, I looked online to see about the Caspian Sea and the Great Lakes. Straight away, there was an article dated 6th of March. The very first words. The Caspian Sea does have tides, right? What can you do? What can you do? It was dated the 6th of March 2026. That's when this thing had been written. This is what they do. This is what they do. Something like that. They'll just digitally change everything. So anybody who has been listening to me and had thought, right, hang on, let me just go and check about these non-tidal lakes and seas. They're not non-tidal anymore, folks. And that is how the cookie crumbles. But whether they are or not, see, you can only patch so much up. This stuff, the distances, the sizes, and oh God, there's one person who says, but there's an equation. There's an equation for the gravitational. An equation? You mean gravity? An apple? But he managed to work out an equation with it. Is it calculus? So apple falls from a tree. Apple. Gravitational pull. The moon. That's what it is. I'll make up mathematical stuff. I'll call it calculus. And what will happen is, if I do this, I'll make all of this up from scratch. and 2 times this, the squared, blah, 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 square root. Right, that perfect. And all of a sudden, you have yourself a theory and math that has been made up for it. It wasn't a case of the math already existed, and then let's hope that the apple falling from the tree just so happened to slot in with the math that there already was. No. We invent other math to prop up the gravitational theory. We actually have equations and stuff that we make up. Calculus, I'm sure. And you'll find that it's all tickety-boo. It all fits in. It's good how you can come up with a theory and then make up the math to support the theory. It's a fantastic system, isn't it? Guys, it's a joke. It's a joke. You write Simon down. 30 Earth diameters away. 30 Earth diameters away. And it's dragging dragging the water on this planet. And the sun ganging up on us. But none of the other water bodies, the bodies of water, are doing anything. Well, they are now. 2 centimeters apparently, the Caspian Sea. It wasn't before even 2 centimeters. Maybe they should have gone for a little bit higher than that to make it believable. Nah. It's ridiculous. Look at the sizes. Look at the cancelling out when both of them are... How does that happen? It's just horseradish. Nah. The moon has no gravitational pull, because if it really did, first of all, there would be more of a uniform pattern as it's going around where the tides are. You can't say that, but it doesn't matter where the moon is. It won't ever be necessarily above a high tide. It could be above a 1/16 of a high tide, or a 1/8 of a high tide, or a quarter, or a half, or 15/16 of a high tide. It's all coincidence. If it happens to be above, exactly directly above a high tide, it's purely coincidental. They say that. So where's the pattern? Where's the pattern? There is no pattern. There is no pattern. How does Bristol get a podium finish with the 3rd highest tide on this planet? And it's facing the wrong way of where the bulge is going, not to mention that it's fairly up north. How did that happen? What is the science? It's the shorelines and the shape of the coast. No, it isn't. It's something else is displacing the water on this Earth. It's not gravitational pull from the moon. There's too many inconsistencies, and they are obvious inconsistencies. You don't have something pulling from the 12 o'clock position, something pulling from the 9 o'clock position, and cancel each other out. It's illogical. All right, that's my boy. I'm gonna call it a day for now. Folks, 2.4 times the size? We're 3.6 times bigger. We've got 6 times as much gravitational pull, allegedly, than that thing down there. 12 times as much as the sun. That's 3.5 k's away. Yet, look, what we need to do is get common sense back. Then you'll understand what I'm saying, won't you? Folks, the absurdities continue. Don't need Newton's absurdities to diss this. It's all illogical. It's ridiculous. And how did they know that there is a bulge so early on? It's the same as light. They commandeered it early, and they've kept hold of it. That's why they just keep pounding it and pounding it and pounding it. There's too many questions that need asking. All right, folks, later.